In this lesson, we're going to go over some of the things from grade 9 about lines, the equation of a line in particular, mx plus b, hopefully you remember, that are important for us when we look at this next unit. Our next unit is all about analytic geometry, so analyzing things using geometry, using lines, if you will. So, first idea, slope, or gradient as IB calls it, and I'll use those words interchangeably, can be calculated in two ways. First way, use a picture. If you have a slope, you can count your rise and run. Rise goes up, positive. If you go down, it's negative. And if you can, you always want to work from left to right. So your run is always a positive that way. If you don't have a picture, however, and you have just coordinates, for instance, 2, 3, and -4, 1, well, then we have a formula for slope. The formula for slope is y2 minus y1. So reminders, x and y, and you'd have to subtract the y's and then divide by the difference between the x's. So let's take a look at this first example here. Determine the slope of the lines joining A and B. So two different things. I got a picture one, I got some coordinates. So for A to B, with the picture, I can count. I can work from the left to the right. To do that, I have to go up 1, 2, 3. So my slope is up 3, it's positive. Then I have to go over 1, 2, 3, 4, 5, 6, 7. There's my slope. Up 3, right 7, or in other words, 3/7. If I don't have a picture, however, and just have coordinates, I don't feel like drawing it, I can do the math the same way, but I need to use that second formula. So my slope here would be y2, which is 7, minus y1, be careful there's a minus sign and a negative sign, over x2 minus x1. Now, if you had chosen to do the other direction, other order, you could have done -5 minus 7 and 3 minus 1. Order doesn't matter as long as you're consistent. You either work this direction or you work this direction. I'm going to use the bottom one here. So 7 minus -5 is 12. 1 minus 3 is -2. And I want to calculate that -6. Just to point out up top here, you would have got -12 over +2. Also -6. So order doesn't matter as long as you're consistent. That's how we calculate slope. Some things we should know about slope. There's relationships between lines. Idea number one is parallel. Let me use the railroad tracks as parallel. So things that are parallel, that means they have the same slope. We also have perpendicular, the upside down T. I'm going to use that symbol a lot because writing the word perpendicular out over and over again, it's time consuming. For perpendicular, we know their slopes are negative reciprocals. In other words, if you look at your slope, and the first one here is 3, which is actually 3 over 1, it's perpendicular to this one, which is -1 over 3. The fraction has been flipped over and the sign has been changed. Okay, so 3 on the top went to the bottom, 1 went to the top, and we switched our sign. So for instance, if we had another one, let's say we had 2/5, its perpendicular would be, flip it over, 5 over 2, and because the original was positive, the opposite has been negative. Okay, that's perpendicular slopes. Let's look at the next example here. For the following, write an equation for a line that is parallel, or to perpendicular. So, if it's parallel, that means it has to have the same slope. So I need to identify my slope, which is 1/2. I need to make a line that has the same slope, but a different y-intercept. This part has to be different. So I'll pick a different number. Oops. Make sure you have an x in there. If I want something that's perpendicular, I have to take my original slope and find its negative reciprocal. So I need to flip the 2 and the 1, put it the other way around. And because this was positive, I need to make mine negative. And again, I can pick any number for the y-intercept. That part doesn't matter. Now, we don't usually write -2 over 1. We usually is just -2x. And you try the next one. Something parallel means I need the same slope. That's easy enough. Something perpendicular, I need the negative reciprocal, so I flip it over. Remember there's a little 1 underneath there. I make it positive because it was negative. and I pick some other number. Okay, there's parallel and perpendicular. One of our big ideas is we need to be able to write the equations of lines. So unless it says otherwise, our equation of line is always in the order y equals mx plus b. We know from last unit this is a good form for graphing things. We can graph it really quickly. That's why it's helpful for us to put it in this order. But to make the equation, we need to know m and b. So if we're given the slope and the y-intercept, just fill them in. In the first example here, it says write the equation of the line with slope 2/3. There's m, and a y-intercept of -6. Well, there's b. So I just have to put those in the right spots. Y equals 2/3 x. Don't forget the x. And plus b. Now, b happens to be a negative, so I didn't write plus minus. It's just simpler to write minus. So -6. Let's look at the next one. Write the equation of the line that is perpendicular to 2x minus 5 and the same y-intercept as this equation. So I need to interpret some math here. We know what perpendicular means. It means our slopes are opposites. So the slope of this one is 2. It's perpendicular, here's where I'm going to use that symbol for perpendicular, is the negative reciprocal. So I need to flip it over, 1/2, and make it the opposite sign. There's my slope. I need this piece. But I also need a y-intercept. And we were told the y-intercept comes from here, the same y-intercept. But I can't see the y-intercept. This thing is not in the right order, mx plus b. So I need to fix it. To fix it, let's take the 3x and move it over here. So we'll end up with -2y equals -3x plus 6. Now I've got the mx plus b part going, but I don't have the y equals part. I've got this -2 out front. So I need to divide out that -2 to get y equals. So if I divide one side by -2, I need to divide the other side by -2. So I end up with 3/2 x. I just cancel out the two signs. 2 negatives make a positive. And 6 divided by -2 makes -3. And I was doing this because I was told it has the same y-intercept. So I need the y-intercept. B is -3, right there. Now I can take my two pieces of information and make my new equation. Y equals mx plus b. Okay, so I wasn't told specifically, here's m, here's b, but I was told things about them so I could find them pretty easily. Let's look at the next set. What if we're not given them? What if we're given parts of them? Well, if we're given a slope, an m, I can always fill that in. If I'm given a point, that means I can solve for b. So we're going to substitute our slope, and then we're going to calculate the y-intercept. Let's look at the example. Write the equation of a line with a slope of 3. Oh, there's m right there. That passes through a point. A point is made up of an x and a y. So I can fill in what I know right off the bat. I know m is 3, but I don't know b. I can find b, however, if I can fill in these numbers, which I know because I was given a point. Y is 4, x is -1. All I'm missing is b. Let's solve for it. We'll get rid of our brackets. We'll rearrange. We'll bring the 3 over here, so it becomes a +3. And now b is 7. So my equation is y equals 3x plus 7. Done. Okay, you guys can try the next one again. Write the equation of the line perpendicular to this thing. Oh, perpendicular. So I'm not told the slope, but I can find the slope if it's in the right order. So let's do that. Let's put it in the right order. mx plus b, but I don't want 2y, I want just y equals. So I need to divide all by 2. Okay, I was doing this to get the slope, but I didn't want the slope, I wanted the perpendicular slope. So my perpendicular, if I flip it over, becomes 2/3. It was negative, so now it's positive. Okay, I've got myself a slope. Y equals 2/3 x plus b. I can get b if I know an x and a y, and sure enough, I do, x and y. So 4 for y, x is -3. Let's find b. Okay, oh, we got to do fractions here. Reminders about fractions. When you multiply them, you go straight across. So 2 times negative 3 is negative 6. 3 times 1 is 3. I can calculate this because negative 6 divided by 3 is negative 2. Rearrange it. Let's bring the 2 over here. It becomes a plus 2. And b is 6. Therefore, my equation is 2/3 x plus 6. Done. Yeah, that one was slightly more challenging because we weren't told the slope. We had to figure out the relationship about the slope. Now, one more thing we can do with these kinds of lines. What if we're given 2 points? Well, if we're given 2 points, we don't have a slope, but we can find a slope with what we started with today, using our slope equation. Once we know that, we can put in the slope like we have been, and we can use one of the given points to determine the y-intercept. So if we look at this example, find the equation of the line through R and S. R and S is made up of this 2 points, which means I can find my slope, negative 5 minus 3, and 1 minus negative 7. If we do that, we get negative 8 over 8, which simplifies to negative 1. So now I know my slope, negative 1x plus b. To get b, I need an x and a y. And I've got 2 different choices. I could use this one, or I could use this one. I'm going to use point R. So from point R, y is 3, x is negative 7. We're going to calculate. So I get 7 plus b. 3 minus 7 is b. Negative 4 is b. Therefore, our equation is negative 1x plus, minus 4. Done. That's it. Okay. Okay, last idea for today. Some special lines, some weird ones. We're going to come across some weird lines from time to time, ones that are either vertical or horizontal. Vertical ones are weird because they have an undefined slope. It doesn't exist. You can't calculate it. There's a rise, you go up, but there's no run. So in other words, you get a slope of something like 5 over 0. If you try calculating that, you can't. You'll get an error on your calculator because you can't divide by 0. So when you come across a vertical line, you can identify it because it has a weird equation. It has x equals as the equation. And x equals whatever number it happens to go through. Maybe it's x equals 2 because it always goes through an x value of 2. On the other hand, you have horizontal lines. They have a slope of 0. And the reason that is they have a run, so they go over, but they don't have a rise. And 0 divided by 5 always comes out to 0. 0 divided by anything always comes out to 0. So these equations have an equation in the form y equals, but 0 for the x. Well, 0 times x doesn't have any meaning, so we usually just write down y equals and whatever number that happens to be. Maybe it's 3, maybe it's something else. We don't know what it is, but it's just a number. It's a flat rate. So if you look at this last example here, determine the equation of the line that passes through negative 5 and 6. That is A, vertical, and B, horizontal. Well, negative 5, 6 is right about here. If I want a vertical line to go through this, okay, every single number on that line, for instance this one, is negative 5 and 5, negative 5 and 2, negative 5 and negative 1. What I notice is that x's are always the same. In other words, x is always negative 5. A tricky way is, a cheating way is, x is negative 5. In the same way, that kind of makes sense that my y value, if it's going to be a horizontal line, always has to be 6. And it would have to go this way, and every single point along that line is going to be something in 6. 4 and 6, 1 and 6, negative 7 and 6. Y is always 6. So those kind of equations are actually pretty quick to do if you recognize that you have a horizontal or a vertical line. That's the end of that lesson. Our homework's a handout today. The first couple of questions are multiple choice, so just circle the right answer. Answers are on the website. You can check them out. If you're stuck with some things, come see me. We're going to be making lots and lots of equations this next unit. So the meat of the lesson is making those equations. You need to practice those.